Good morning. Happy Monday, everyone. Just getting warmed up. Literally. Nice and crisp out. So very crisp. Hope you all had a great weekend. All right. Where were we? Let's see. Let's run the tests. I think I left myself a little to do via some panic. Yes, there it is. But it failed. Again, we are in the Reverb platform. We are working on data archive. We will be receiving information from the writer and sending it to the reader. Data archive will store the data into the storage cluster, and in production it would be TiKV. For local testing, we are using SLED. We've built out a little interface for our storage cluster so that we can run our tests against SLED, and we're starting to implement the reading APIs. Or rather, the replication APIs, as we will see. Just checking on the. Okay. Interesting. I've dropped 25 frames. Bum, bum, bum. All right. To the code. What if the DB is deleted? Yes. Great, great, great point. Okay. To look at the test again, we're calling get databases. So we set up a new test context. We have our database. Excuse me, our database is inside of the test context. We have a shard, which we now send. We call get databases. The server responds. We get an empty set. We put some data into the database. We call the same API. We get a response with that name. Now, it didn't do the full request. Okay. The request was only looking at this namespace. We need to look at both. So it will look here, it will look here. It will look at the contents of this one to see whether or not the database has been deleted. Oops, deleted a little too much there. Just thinking over whether or not this information should be included here. Because of the compare and swap, I'm thinking no. But maybe is deleted should be part of the compare and swap. Transaction ID and checksum, absolutely. But is deleted. No. Is how frequently are we expecting things to be deleted? Let's say somebody is deleting, creating, deleting, creating, deleting, creating, just doing something like that, and the machine goes down, the writes end up going to the next machine. What do we want that in here? Maybe? Mm-hmm. And then if we have that, why not just include page size? This is mostly static anyways. It's basically just going to keep us from having to look up the first page to retrieve the information. I think I'm leaning towards getting rid of this. It does mean that somebody updating checksum and transaction ID would need to keep around whether or not it's deleted and the page size. Okay. I think for now, we're just going to move is deleted up. We'll leave page size here. It might just go away, as we could just look it up here in the page data. Oh, I get my music going. Where's my headset? There we go. All right. It's deleted in there. As we implement this piece here, we're looking at, well, we'll be getting a range. Hey, Raphael. Oh, look, cheap yours. Yeah, you're going to be banned. Scott, I'm doing well. Doing well. Gonna ban Raphael for a moment. Actually, Raphael gets reported. Let's see. Report for spam. Um, yep, spam. Report, block user, done. Bye bye, Raphael. Yeah, Scott, doing well. Had a relaxing weekend. Really relaxing weekend. How's your weekend? Tests are in replicate. Where our code is. Let's look up to see where our code is. Get databases. Instead of using range keys, we will use range. And the interface on that is identical with a different output. Rename this to range pairs. Range pairs. Vector of vectors. I'm going to change the interface on this. Does that make you a cheap viewer? I don't know. Um, I don't think you're a cheap viewer. I mean, unless Raphael sent you. It's like puppy dog sale, right? Let's say, spend most of the time. Oh, ski lodge, nice. Kids becoming a ski instructor, that's cool. Ah, and you were doing rustlings at a ski lodge. That sounds awesome, actually. You're stuck at the second quiz in rustlings. Well, let us know if you have questions. Now this is sled, so in this case, take limit dot map. Oh, no, unwrapper default. How about unwrap or? And this wants a U32. What was it? No U size. Okay. We want the TiKV implementation as well. This scan takes a U32. Unwrap or. We actually want U32 max here. Okay. So if client scan, map it to the max. If it's a none, back to replicate. So now we get the pairs. Pass that through. Range database has failed to range keys error. That's fine. Do not need to update that. Range pairs. Now we have more than just names. So now we have tuples. The name is the first piece. We have key and value. Do a little destructuring there. Value is not used. In this case, we would also want to push the values in. Okay, let's rename this to result or pairs. Result pairs seems descriptive enough. Pass name and value. Oh, my mistake. No, this is for the request response. It should not be pairs. It should only be strings. It should only be the names. However, we need to filter out the databases that have been deleted. So if value, after it's been deserialized, includes is deleted equals true, then we skip the push. Something like so. We even have Saturday. And how do we want to store the data? Should it be JSON? It's nice and human readable, but not very performant. You can actually store it as protobuf. It's stored as something else. Okay, we want Saturday at least. Let's go to the home page. Using Saturday, where's the big list of implementations? Here we go. Wow. Postcard, I think, is very, very fast and thin. But does this suffer from version changes? Like it has to be exact. As of version 1, stable wire format. I've been wanting to use Postcard in one of my other projects because it's nice and it is quick. Okay, design goals, no standard. Maximal set of Saturday features. Oh, that's right. You can use it without Saturday. Avoid special differences in code between communication code written for a microcontroller or a desktop server PC. Interesting. Resource efficient. Sounds lovely. Memory usage, code size, developer time. We got time. So the example uses Saturday. Heapless vec. Oh, how fun. Trying to remember what the other project was that I wanted to use this on. Was it this project? Maybe a portion of this project? I think it was a project before this. I'll have to look that up. Okay. We've got hello. Oh, what's this one? Alec feature. Okay. Flavors. Interesting. I kind of want to test it out. Where's the link? Here it is. Non-describing format. Non-self-describing format. Often as a common Rust data type. I think we'll be okay there. Yes, okay. I was wondering about this. Do we always have like a header byte that describes the version of the data? It's not very difficult, right? Far ends encoded integers, fine. Okay, now how it's actually implemented. That's fine. This is what I wanted to see. So we will take that into account. And we'll just have a couple bytes just before that describe what version it is. And that's easy. Let's look at the docs here. Now we don't have to use Saturday with it, right? So it can be used as a drop-in replacement. Now I'm not against Saturday. I just wanted to see their API. Obs encoded byte slice. Interesting. CRC32. Ah, this is the checking, right? What is a COBS encoded byte slice? Consistent overhead byte shuffling. Stuffing, excuse me. You can recover from malformed packets. Fancy. I don't think we'll need that. And what is heapless? Static friendly data structures that don't require dynamic memory allocation. We don't need that, but that's interesting. Take from bytes. And we have flavors. One, to use multiple flavors. And what is a flavor? Flavors in postcard are used as modifiers to the serialization or deserialization process. I see. For the cobs or heapless. Using a single flavor. From flavor slice. I see. Let's start with Saturday and just do the default. Yeah, I don't want to use heapless though. What is the alloc crate? Oh, that's the Rust core allocation and collections library. I did not realize that was outside of the core. Outside of core. That's neat. Could we end up with two versions of Vec? To alloc Vec. I don't think we need to include this. I think we can just use standard if it's the default. All right, let's add Saturday. Add. Oh, wait. It's a little bit more complicated. Okay, we have Saturday, Saturday JSON. We want postcard. And what are the features we should be aware of? I want to use alloc. Let's do use standard. Okay. I'll go add. And this will be for data archive. We already have postcard? Really? You're kidding. Oh, that's right. I was using it for some of the raft pieces. Oh, wow. Okay, well, let's update it to version 1.1. Use standard, use CRC. Okay. Looks like it's already there. Great. So now if we're using postcard for this, and okay, one of the reasons I wanted to use postcard was because it's supposed to be very quick. Start a benchmark postcard. Lots and lots of numbers. Numbers, numbers, numbers. Business. Wow. No graphs? Boo. So postcard here. What's the second column? Deserialize. So serialize is fast. Deserialize looks slow. What is the last column? Standard. Okay. Size, elib, z standard. This is for large amounts of data. Relative to best, higher is better. You know what? I think it was archive that I wanted to use. And but I ended up using postcard because it was good enough. Archive, yeah, archive is bloody fast, but it's got some limitations. Zero copy deserialization framework for Rust. If I remember correctly, it has the same sort of issues that everything has to be on the same version. Motivation, performance, the way that it achieves that goal can also lead to gains in memory use, correctness, and security. Most frameworks like Sarday define an internal data model. Okay. Front end takes some type and breaks it down into serialized types of the data model. Okay. Time adds up quickly. Zero copy deserialization reduces the time and memory required to access. Yes, tell me more. Well, zero copy. Hmm. Archive does sound nice. What are the downsides? I do not remember what the limitations are. And support endianness. You can disable the alloc feature. If you skip validation, then yes. Hmm. What about versioning? I think we're in the same boat. We would have to, yeah, basically set up our own versioning. That's okay. All right, I want to play with archive. Sister crates. Why would you use one of these? Oh, okay. These are the crates that archive uses. Got it. So coming back to our cargo toml file, what do we actually have in here? Do we have archive? We do. No? Oh, we did. All right, well, here we go. Okay, so we'll add this to data plane. Oh, look at all these features. We want standard. Let's just start with standard. Okay. I think we're okay with the rest of them. Maybe we might want something like Big Indian. Something like that. All right. We want data archive. Did this not get added to data archive? Where did we add it? Data archive. Hmm. Obviously, it thinks it did something. Oh, I put it on data plane. Wrong one. It should have been data archive. Archive. There you are. Okay. Let's go here. Add it. Alphabetic order. Lovely. Done. Deleted from data plane. Wait. I just put it right back in data plane. Close data plane. Add it to data archive. There we go. So coming back here to the code, where are we? We are inside of get databases. We are handling a tonic gRPC request for getting the databases that are stored. We need to look at the value that's stored in our database, deserialize it. You know, it just dawned on me that It might be a little bit more complicated to use to set up the unit tests now because we're going to use archive. Hmm. Oh well, we'll see where it goes. Anyhow, so we get the data back out. We need to check the value of this to see whether or not it has been deleted or marked as deleted. So how do we use archive? Here's the documentation. It will use Little Endian by ordering by default. Pointer width. I'm sure the alignment and pointer width go together. Rotation has all of these different types in it. Right, serialized, deserialized, functions, 2 bytes, from bytes. So we give it the bytes. Byte check and alloc only. High level API. Okay. Module high. They have a high API. Oh, that's great. 2 bytes from bytes. 2 bytes in, 2 bytes. Okay. So give me mutable reference. Interesting. Maybe let's add byte check. Or we use deserialize. Deserialize a value from the given archived value. Bytes. Archived example. Okay. We deserialize. Archived example. To example. Seems pretty straightforward. We need a versioned element here. All right. I'm not worried about space, so we're just going to use like a U32 or something like that for the first 4 bytes to track versioning. And then we will append some data after the fact. Okay. Let's see. Let's import some archive bits. Oh, but here, the first thing. We need to have some sort of structure. What structure do we want? Struct databases. Basically for this data here. This has information about a database. What is it though? We have database info here. Database state. Yeah, let's call it database state. Database state v0. v1. Let's be optimistic. And inside of it, we will have is deleted, checksum, and transaction ID. Checksum. What is our checksum? Is it a U32? And transaction ID. And what is our transaction ID again? I think we had a big long conversation about that. I think it's a string. No. Yes, warm fuzzy. Okay, so we have a epoch, the salt, and that. So yeah, it's a string. Right now we need to annotate that. And what were the annotations we needed? Archive, serialize, deserialize. Do we need partial EQ? Oh, for the unit test we did. Okay. Now this information we should probably have higher than this replicate module. We toss this up in lib for now. Maybe we have types. Okay, so we've added the derives for database state v1. Now we need to deserialize it, which would be we take the bytes. We need to check to make sure we're getting the right version though. Hey Xenocron, how are you? Database state v1. Let's just qualify it. I think I want some sort of some commonplace to serialize and deserialize these things. I can complain. Glad to see some Halsey code while having fun with UE blueprints. Oh, UE blueprints. Man, I have spent some time in there. It's it's interesting. How's it going? It's going all right. Yeah. Working on a little bit of some unit tests. Have database state set up here. Um, Working on using archive for serialization. You know, for funsies. And I think I want to abstract out the deserialization piece because I want this to be one of the versions. Basically want types for this. So enum database state, right? V1, database state V1, something like so. And then it can serialize and deserialize the different versions for us. Sounds like the C++ way of doing binary deserialization. Well, you got me there. And I love me some C and C++. Then we can impl database state in order to hit the right version. We'll implement database state. Function serialize. CRIAL. Come on, me. Do we need to consume self for archive? I don't think so. And what do we want back? A vector of U8s? Something like so? I don't know. We'll find out. Let's go back over to our documentation. You sure hope that I don't have to consume self. Yeah. The winter's not that cold. Value. 2 bytes. 2 bytes is here off of archive. What is this here? What is access? What is archive access? Access a byte slice. This is a safe alternative to access unchecked and is part of the high-level API. And we're doing that instead of using 2 bytes and from bytes. Oh, because from bytes requires byte check. So I was looking at deserialize. Well, let's see what happens. Well, let's just be explicit here. And what is our error type? I don't know. The trait bound types error rancor source is not satisfied. Oh, tell me more. Where rancor source. Snafu, it's like an alternative to anyhow or this error. Um, it allows you to kind of compose errors as and to have errors specific to the code that you're working on, like for the module or for smaller pieces. So in this case, um, let's see, do I have one in here? I think I do. Here, cluster management error. This is in, well, cluster management. So it's similar to like this error in that you can kind of map one kind of error that you receive to a common type. It looks very, very similar, but the way that you use it is different in that with this error, you end up not having as many error types. So with Snafu, you're encouraged to have basically an error type per module at least. Be descriptive and um, let's see if we can find a place where we use it. So here you can see that this telemetry initialization could result in a error. And so you convert it to your error type using with context, and you say, oh, this is a telemetry init snafu. It automatically adds the error information to this and associates a telemetry init snafu with the telemetry init error and auto-populates the error piece here. You can have additional pieces of information, such as this bind error. We search for bind snafu. Here we go. And let's say you don't have a source, right? You don't have to use with context. You can just create the error. So I like it. Um, I'm tending to favor it over this error. Pretty neat way to map error. Yeah, I like it. It's a little verbose. I do find it a little bit more verbose than this error, but it's working for me. Oh, I heard a door. Just a moment. All right, 2 minutes. All right. So, hopping back into it. Reverb data archive, yada yada. Where were we? Oh, yes. We're implementing these pieces. So let's say we want to serialize it. We serialize it to a specific version. Oh, and that's right. We were looking at error, not implementing rancor source. Trace plus error. What is trace? Rancor trace. It's error. Okay. I do not remember seeing anything about this here. What is error? Rancor error. Do we have to use Rancor error? Rancor provides scalable and efficient error handling without using type composition. Okay. This is... And our traits here. There's source and Rancor struct error here. Uh, all right. Well, it looks like we do need to use Rancor error, but I'm not sure. I'm not certain about it. So 2 bytes. Oh, where it's Rancor source. Okay, well, we can implement source for that. What is source? Well, maybe we can. Let's find that out first. Trait. So we need new on it. Okay, we can do that. So let's implement Rancor source for our error type. Wow, typing today. Implement Rancor. My missing members. Source unused. Trace is not satisfied. Uh, okay, so we also need to implement trace. We have error. This should be a standard error. Yes, core error. Good. What is trace? Trace adds an additional trace to this error, returning a new error. Interesting. R is format debug. And where is trace? Is it just in Rancor or is it re-exported in archive? Are there re-exports? No, we have to. There we are. There it is. Okay. No, this is Rancor. I want. Come on, keep going back. Oh, it's not there. Archive. Here we go. Re-exports. Rancor. Okay. Impl RKYV. Oh, it's right below that. How did I not see that? All right, so now we've implemented both of them. Yes, to do, of course, we will eventually get to that. Coming back here, vector view weight, found unit. Okay, yes. value impls for serializer. Not gonna lie, it feels a bit odd having to provide your own error type. Yeah. In this case, though, I can imagine that archive is being used in places that are maybe constrained or trying to be uber efficient, in which case you might want to have your own very, very light error types. Two bytes value takes a reference to that. Okay. Rate bound for blah is not satisfied. Aligned vec arena handle share type error is not satisfied. Hmm. So apparently our oh, my mistake. This should not be here. This should be up here. Well, probably in both places. Now what? Oh, it's consider removing the leading reference. Yes. Now we just need a vector of U8s. This is an aligned vec. What the heck is an aligned vec? Vector of bytes that align its memory to the specified alignment. Hmm. Reallocates and copies the underlying bytes. Boo. What is it though? Let's look at the source. Capacity length. Pointer. Non-null. Hmm. I didn't want to reallocate. Let's go back to our high level. Where's high? Here we go. We could give it a writer. Or W is writer. Or we use the aligned bytes. That's interesting. That's neat. The const. This is not about the error type. This is about the resulting type from the serialization. So in this instance, when we take our data and convert it to bytes, it is an aligned vector as opposed to a regular vector. And it looks like the aligned vector, you provide the alignment as part of the type. That's neat. So when you do that, okay, with capacity, let's go to with capacity. Alignment must be one or more. Okay. I like that these are compile time checks. Right, this, well, no, it's not. It's not. This is an assert. It should fail. I wonder, could they make it? Well, only if this was a const function could they make it compile time? Capacity, let's see, self. So if it's 0, do nothing. If it is something, we layout from size aligned unchecked. Boom, here, allocate. Yeah, it's allocating. No static assert. Yeah, no static assert. Not yet. Maybe someday. Okay, I do not like that this type would kind of leak out of our interface. I don't really want that. Aligned vector. So if we don't use that aligned vector, we would have to say 2 bytes in, or 2 bytes in with alloc. With arena, okay, blah, blah, blah. So here they're providing an aligned vector again. Bytes with alloc. It does have as slice though. Oh, interesting. All right, so how would we end up using this? We would serialize it, and then we would need to send owned data to TiKV. So TiKV would then need something that could implement. Let's see, what's our interface have in it? Oops, closed the wrong file. We have storage. So as long as, yeah, has asref u8. So maybe it would work. Yeah, Intivec ends up allocating for it, which is fine. I don't know why I'm worried about allocating. I just don't want to do the work if I don't have to do the work. But we do take asref u8, which I think this would be okay. All right, let's go with it. Let's go with it. So coming back here, implementing this phrase. Oh, skipping those pieces. Deal with that later. We end up with an aligned vec. There's no... Wait, I thought there was. Oh, I'm sorry. This is because my return type is awful. Okay. There we go. Now, this isn't quite right, as we need to know what the version is. We want to serialize it, so let's keep that bytes around, like so. Oh, you know what? You know what I was going to do? I was going to prepend this with a little bit of data describing what version it was, so I could then take that off later and use it. So I could get an aligned vec and then use one of the other interfaces. Does it not support tagged unions? Oh, you're right, because that's what this is, isn't it? Itself. This would be a tagged. Absolutely right. I was going to implement it manually, but you are absolutely right. Wonder what that would look like. Data union and sin. Hmm. I think my concern is that the union is not oh, no, not a killjoy. These are just things going through my head. Um, not at all. Is my concern here is that the database, well, the tagged union wouldn't be consistent between versions for some weird reason. Like if I added v2, somehow that changed v1. worth thinking about. Um, let's do a little quick search. Archive versioning with tagged union with let's call it enums. Add write example for backwards compatibility via enums. Oh, maybe they did do that. Door latest. What? V1, V2 latest. Oh, they have an example. Increase the size of the enum by adding C but keeping A and B the same. This should work since I haven't changed A or B, but see, this is what I was wondering. Context error, out of bounds. When the C variant is added to test, the size of test increases from size of discriminant. Oh, look at that. This breaks binary compatibility because even though the first two variants haven't changed, the overall enum has an archive checks for enough memory for an archive test before checking the enum discriminant. Way to work around this is to make sure that size of test never increases by boxing all of your enum fields. Okay. Discriminants for archived enums are now required to always be a single byte. So the previous example is now comprehensive. The linked example, backwards compact, looks comprehensive enough to describe how to add backwards compatibility support to your data format. All right, let's look at backwards compat. Oh, examples, archive. Oh, it got reorganized. Example v1, v2, versioned. Okay, I like it. We'll pick up on this. I need to run. Huh, I clipped that. Didn't mean to. We're gonna raid Future Highway again. So I'm glad we found this. And I do not think it was a bad thing to hop into at all. I like this. Well, take care, y'all. Good to see you, Xenocron. Till next time. Bye bye.